Okay, hello everyone. Welcome back. Yeah, so today we have AI space here. Okay, so yeah, and then maybe while we're waiting for more people to join, and then maybe we can have a chat first. Yeah, so just give our audience some time to to join in, log into to YouTube, and then and click on our this sessions link. Yeah. Okay. So hi, how's everyone?
Good. I'm good. What about the
Mm,
speakers here today? We have so many of you.
yeah, I think this is the first time that I think we have such a big speaker group. Yeah, a
Wow.
big
So
speaker.
honored.
Yeah, yeah. So I actually looking forward to the session. Yeah, actually, I'm very curious. Like actually, I very to be honest, I'm also very new to AI space. I think AI space itself is actually very new in Singapore. I think in the region as
Yes.
well. Yeah,
Yeah.
actually, I'm just curious. Like how do you all actually get into AIs? Yeah, like what make you choose AI as a degree? Yeah,
That's a good
Rama.
question.
Yeah, Rama. I'm actually interested. Like Mark, how do you actually join? Yeah, how do you get into AI?
So I started off as a developer, and uh, I think as for AI, I enjoyed the process of discovering underlying patterns and interpreting data, rather than just building an application or following the software development cycles, which is boring. And I think like working in the field of AI or something like data analyst, compared to software engineer, or yeah, they're more towards the technical side. And like for example, what in data analyst, then it's like the intersection with like a good balance between business elements and technical elements. So then yeah, which is what I prefer, rather than just purely working in the software engineering side. Yeah.
Oh, okay. What about you, Rama?
Software statistics society, so a lot of the computer vision and
Oh, okay.
that's
Rob, I'm gonna stop you for a while. Yeah, I think your audio has some issue. Yeah. Okay. Yeah, no problem, no problem. No problem. Maybe you want to do some rectification first. Okay. Yeah. So don't worry. I think guys, I think we're gonna start the session pretty soon. Okay. So I just want to address everybody. So if you're tuning in, from Indonesia, from Singapore, just say hi, and then you can actually put your comments in the comment section and tell us where you're from. Okay. So just say hi to everybody. Give some encouragement to our speakers today. Okay. Yeah. So yeah, I think probably we can start the sessions now. Okay, Wei.
Yeah,
Great. So I
sounds
think I
great.
think yeah, I think I will move everybody backstage. Yeah. Okay, just give me a second. Yep. Okay. So great. Let's start. Okay. Just give me a second. Yeah. Okay, so great. Yeah, hello everybody. So welcome to Developer Space Channel. And then thank you all for tuning in to the live stream of this evening. Yeah, so we're very excited today. We actually have a new partner, AI Space. Yeah, so and this is I think the first time we were working together. And then hopefully we can bring more AI content to the community. Yeah, so a fun fact, so Wei Xing is actually one of our speakers previously, and then and she started the AI space, trying to hope to actually contribute more to the AI community. Yeah, so she'll share a little bit more about the space later on. Yeah, and if you are interested to know more, you can actually connect with her later on. Yeah. So yeah. So for before we begin, right, let me briefly introduce who we are and what we do. Okay, so Google Developer Space is a platform for developers and startup around the region to learn, connect, engage, and be inspired. So I'm Lawrence from Google Developer Relations team, and as part of the Google Relations team, we aim to empower and connect the community with our people, programs, network, and technologies, be in person or online like today. Okay. Yeah, so if you actually like our content, please follow us on our YouTube channel. Yeah, so you can actually scan the QR code and it's linked to our YouTube channel. You can actually view all the contents over there. Yeah. So yeah, and then maybe now, Wei Qing, you can actually give us a brief introduction what Space is about.
Yeah, sure. Hi, everyone. I'm Wei Jing, and I co-started AI Space with my friend Cleon, who's also tuning in. Yeah. Anyway, AI Space is a community of AI enthusiasts. All of us are looking to learn more about AI together and also build meaningful careers in AI. So many of us come from different backgrounds, including myself. I come from social science. I have friends that come from finance, engineering, statistics, yeah, everywhere. So we really welcome everyone to join in together in this community, whether you just want to learn more about AI, are curious about it. Yeah, and here are some of the links they can join us to know more about what we do.
Yeah, so yeah, if you're actually interested to know more about AI and you actually need mentor, you can actually join their LinkedIn profile, their Telegram, and their Discord channel. Okay, yeah. So yeah, so first up, I think let's welcome our first speaker for tonight. Yeah, and she's Xingyu. So she'll be talking about how her team actually matched K-drama couples. Yeah. Hi, Xingyu. How are you?
Hi, Singhi.
Hi.
This is a really interesting topic. I
Ready to
really love
sharing all my project.
And is there a K drama that you're currently watching?
Currently, I have no time like watching K dramas because I'm busy with studying, and but I guess I'll come up and watch some when I have holidays.
Yeah, we look forward to what you have for us. Maybe there's some K drama that you're recommending because the couples have such good chemistry.
Yes.
Yeah, so why not we let you take the stage?
Okay.
Cool.
Yep.
Okay.
Okay, you may start the presentation, Xingyu. Okay, all the best.
So hi everyone. My name is Xingyu. Can sorry, can you see my slides? Yes. Okay. Hi everyone, my name is Xingyu. I'm currently a year 2 student studying data science and artificial intelligence at NTU. So today I'm going to share a course project I did in year 1, matching K-drama couples. I did this project together with two of my classmates, Jacinta and Valencia. In this project, we want to come up with a model to evaluate the chemistry between couples based on reviews, so that we can recommend a match for an actor or actress in future productions. So the first thing we did is to collect data. We scraped the reviews and cast information from the website called My Drama List. We use Scrapy to do so, and here's the data we collected. This is the role information and the reviews. We then generated a word cloud for all the reviews, so we have a rough idea of high-frequency words, which can be used as keywords to evaluate chemistry later, like romance, love here. Next is to use the reviews we have to measure chemistry. There are 3 steps. So for first step, for each review, we split it into individual sentences. And then next, we filter them based on keywords, such as chemistry, romance, so that only those with keywords that are kept for evaluation later. So we'll remove those without keywords and then kept those with keywords only. We then try to find couples mentioned in the sentences so that we can do sentiment analysis for each couple. But before we can do all that, there are 3 steps to prepare the data. First is to drop non-English reviews, because sometimes the viewers label the reviews wrongly. So here it's not English, so we need to drop them. We then replace the emojis with its text description. This is because emojis and emoticons contain much emotions in reviews, so we want to capture that emotion. Next, we need to replace all the pronouns with the person they're referring to. This is because people often use pronouns to refer to the actors, and if we don't do this before we split the reviews, we'll end up with sentences like this, which we don't know who they are talking about. For example, their chemistry was great, but we don't know who they're talking about. So to solve that, we use the package called NeuroCoref, and to help it with the replacement, we'll add a conversion dictionary to it, since Koreans' English names are not common English names, and the model sometimes can't tell gender. And we also changed the person's name to this single word format to standardize the spellings, because when viewers read reviews, they use different ways, they use different spellings of the same person's name. And now here's an example of the replacement. We can see the name format is changed from Go-in to Kim Go-in, and also the pronoun is successfully replaced with the person's name, Kim Go-in. In the same way, we'll pass in each review and get the one with all the pronouns replaced. Now the data is finally ready for analysis. Next step is to identify the characters mentioned in the sentences. We use word dependencies to find the couple. For example, here, Gongyu and Kim Go-in have chemistry. Chemistry is the direct object of the verb have, and we need to match the subjects of have, in this case Gongyu. Then we find conjunct of Gongyu, which is Kim Go-in. As I mentioned before, we split the reviews and keep those sentences with keyword. For each keyword, we come up with several patterns of how people usually use these words, so that we can use word dependencies like the previous one of these patterns to find couples. For example, chemistry between A and B are one true pairing, I shape A and B, root for A and B, etc. We then try to find the couples mentioned for each sentences, and if there's a match, we'll append the sentence to the respective couple. Our final process data is a dictionary like this. So the key will be the couple, and then following by a list of all the sentences commenting about this couple's chemistry. We'll then pass the list for each couple for sentiment analysis. Here's an example. We use the polarity score as the score, and it's a number between -1 to 1 as, so here's an example. We can see that if the comment is positive, then it will have a positive polarity score, and if the text is actually saying that I think the main leads have no chemistry, then it will have a negative score. So after that, this is the distribution of our final chemistry score. So now if an actor or actress is already in our database, we can recommend a match based on the pairs we have. What about newcomers that's not in our database yet? One metric we can use is facial similarity. Our idea is that if A is a new actor that doesn't have any chemistry record, if he looks similar to B, we can also recommend B's match to A. In order to do that, we first use MCTNN to crop the images to only the face part. Then we use VGG face, which gives us a feature array of the face. After that, we use cosine similarity to compare facial similarity. This is a visualization of our final results. So our final result will look like this. You can actually click and then choose the actors and then see the meshing. Thank you. That's all for my sharing. Do you guys have any questions?
Like, great. I think this is actually very useful for the K drama producers. So yeah, they can actually use this to pick their actress and actor. Yeah. So to the audience, right? I think if you have any question, please actually post your questions in the comment section, and we will ask the speakers after each presentation. Okay. Great. I think at the moment I don't see any question, but I see there's a lot of encouragement. Yeah, this today I'm receiving a lot of comments. Yeah, so this is good. Yeah. Okay.
There's a
So
question by Mintu. He's asking, oh, what is the next cool thing that you will be trying after this?
oh, I missed it. I'm so
Uh,
sorry. Hi, Mintu.
oh, Hi. So I can answer the question. Actually, for this one, if I have more time, I can actually try to come up with some improvement for the model. So um, I think one thing that I can try is um, actually the co-reference is the pronoun replacement part because as I mentioned before, like we try to replace the pronouns like he, she, or them to the person they're actually referring to. And when we try to do the project, we actually find that the model is doing a great job, but the accuracy is not very high. Um, and so I think if I have more time, I'll look into more. I will look into more models relating to that, and also some part like sentiment analysis. That's also a key part of our project. And because when we do that project at the time we're only year one, so we don't actually have much knowledge about this. So for sentiment analysis, I think what the model did is that it will try to give a score, like a fixed score for the word that has much emotion. For example, greed, they will have a high score for that word and then averaged out so that in the end they have a score for the whole sentences. But the problem is that the model doesn't take the context of the word into consideration. So regardless of the context, the word will always have the same score. But yeah, so that's the model that we use back in year one. But now since we learned more, I think we can try out different models that give us better results, taking the context into consideration. And
Great.
yeah, there are also a lot more improvements, possible improvements.
Yep, we have another questions from Jet. So, are there any surprising things that you found out about the couples?
Uh, well, yes, there is. So, for example, there's one drama, I can't really remember the name, the trip. So I think it's between Gongyu and Kyugu, and they are like the main leads. And in the drama is the score of the drama overall is actually great. That's a great drama, but some people think that they have low chemistry. So yeah, we actually using our model, we actually proved that. So like they're matching for Kyo and Gongyu, but like the chemistry score is very low, which is like coincidence with like the comments and the general thought that we know about this drama. So yeah, I think that's really not say surprising, but like reverting stuff that we have after we come up with this model. So yeah, it's actually working, although it's really simple and there's still a possible improvements.
Okay, cool. Yeah, I hope this answered the question. And then I want to combine questions. Yeah. So, like, how does sentiment analysis account for the local slang or things like sarcasm? And also like how do you consider sarcastic comments?
Oh, well, actually, this thing we didn't take much notice at the time. So, but I think yeah, it's a possible thing that we can look into when I have more time. And this is also like part of the improvements I think I can try out.
Mm, great. I think yeah. So one last question before we move to the next speaker. So it's like how long did it take for you guys to conceptualize this idea, and creating this deck? Yeah.
Well, I would I think I think it didn't take much time, but so for example, firstly we have the idea, but then I think the difficult thing is that how we actually using the existing tools to implement the ideas that we want to have. So actually, after we have this idea, we try whatever we can do. So for example, we first split the reviews, and then we have all the reviews with keywords. That's what we initially planned to do. But then after that, yeah, we have the problem let's say the pronoun problem. So that's the one that we didn't expect at the time. So then we tried to Google and search online on how to solve this kind of problem. And then after that, we found out, oh, we can actually use this model to do that. Then we just apply the model. And then after that, and then another problem after that is that, so for example, we try to find the couples A and B have chemistry. Then how do we do that? Yeah, so after we have that problem, we Google again, and then we find this tool which we can actually use for dependencies to match to match the couple. So I think in terms of idea, we want to measure the chemistry. It didn't take much time to think about that, but it actually took a lot of time when we have problems, and luckily we find the models that can do the work for us. And yeah, I think I hope I answered the question.
Okay, great. Okay, so yeah, and then thank you, Xingyu, for your presentation. And then now we'll move on to our next speaker. Yep. Okay. Thank you, Xingyu. I'm going to remove you backstage, okay? And then I'll add Mark back up. Hi, Mark.
Hello.
Mark.
Okay, how are you
Hello.
doing?
Good.
Yeah.
Thank you.
So yeah, and then I guess Mark will be sharing with you guys how he transit from the web development to the AI industry later on.
Yeah, I think Mark shared a bit about what made him transition to AI. And now my question is, after transitioning into AI, do you have any regrets and do you want to change back to web dev?
I guess at least not now yet, because I'm quite enjoying what I'm doing so far. And yeah, I mean, even though the task could be challenging, but yeah, it's satisfying also at the same time.
That's great. Yeah, we look forward to hearing from you and your story. So over to you, Mark.
So let me share the slides. I think you guys are able to see the slides. Yes. Okay. Good evening, everyone. So I'm Mark Wong, a Year 2 NUS Computer Science student. So today I will be presenting on the topic of how I transitioned from web development to AI, where I'm currently working as a machine learning intern in the AI job matching startup called MatcHub. So I started off as in the area of web development during high school, as fundamental knowledge required for web development was not as hard as compared to the field of AI, and the resources were also available everywhere. And I also enjoyed the way how I can build aesthetic products with an immediate visual feedback. Then I started getting more exposures to interacting with databases and managing data in the backend, like full stack development, because my personal projects also require to store and interact with data. Then I started learning Node.js and different database management, which allows me to easily transition into working as a data engineer, which was my first job in MatchHub, because of the experience interacting with APIs and data when I was working with the backend. So the common knowledge allows me to quickly familiarize with building data pipelines and creating endpoints to serve data. So with more exposures working with Python and different libraries like Pandas, by working as the data engineering intern at MatchHub, I was then able to move on to my current role as a machine learning engineer, where I'm responsible for developing models by myself. So I think one of the most important thing to transition smoothly from position to another, in this case, for my journey from web development to AI, it would be great to do it in a incremental step and learn new topic by building up the common knowledge between topics. So to prepare myself better for working in the field of AI, I also did a few things to smooth up the transition. So obviously keep taking advantage of different online courses such as the MOOCs on the Coursera or edX. And I also think that experimenting with projects will allow you to gain a way better and a deeper understanding into the topic compared to reading it through books or listening to lectures, especially working on project topics that you're interested in. And the other thing that I did was also getting some hands-on experience with real data sets using Kaggle, since it allows me to see how people optimize their notebooks and give me an opportunity to work with real data also. So after building up my knowledge in the area of I was given my first opportunity to work for the first professional project in MatcHub. So I was tasked to create a model predicting work styles from sentences in job description, so that MatchHub will be able to use it to help matching the best fit students and candidates to the best suitable jobs automatically. So at the start, I was given multiple CSVs in different formatting styles. So I consolidated them into a one big data set using pandas and performed some exploratory data analysis to better understand the data set, such as how many examples do I have for particular work styles, etc. And then I pre-process them by performing different steps such as removing punctuation and stop words, etc. Then I tried out different modeling libraries under the guidance of my mentors, and I've tried out different methods such as regression and different ensemble methods like random forest or XGBoost. And on the other hand, I also tried out building different neural networks by experimenting with different embeddings, structures, and layers. For example, like different dropout rate, different number of layers, or architecture, etc. So throughout the developing the model, I have a better understanding on the importance of thinking carefully and dividing the problems and the constraints that the model is trying to tackle, rather than just blindly focusing on the model performance. So, for example, one of the things that my mentor and I discussed about was to evaluate the trade-off between false positive and false negatives to determine the most relevant evaluation metric, since it's more important for MatchHub to identify the possible job matchings and the cost of false positive is less than false negatives. So we decided to optimize and choose precision as the metric. And also the problem of identifying work styles for job description is a multi-label, multi-class problem. And uh, we decided to convert it into a multiple binary classification problems for easier optimization. And also we don't have to retrain everything with, for example, there's a new work style or a work style has to be changed where there's changes need to be made. And also for the pre-processing steps such as stemming, we have also decided to perform stemming because amount of training data we have was not too big. So by stemming and consolidate different forms of work together, we can better identify the relationship between the worst importance to classifying work style. So yeah, this was my first machine learning project and my journey from working as a web developer to developing a new machine learning model on my own, and where this will be used by MatchHub to match job work styles to our users. So I hope this was a insightful sharing that will motivate you to make a career change into the field of AI and join us in the fourth industrial revolution. So thank you, and please feel free to comment your questions.
Yeah, thank you, Mark. Thank you for the good presentation. And I realized that you have a lot of supporters. You can see, wow, you can see that? Yeah. So and we have a question from Justin. Yeah, hi Justin. Yeah, so hello Mark. What was the motivation behind the transition, and how long do you research or prepare for it before you make the switch?
Um, I think the motivation behind the transition is that because there are, I think the potential and the power of artificial intelligence that the field itself can bring is uh, bigger than like what a software engineer can bring, because of the way, for example, if you develop a very well optimized model, it could potentially be applied into different industry because of the way you're able to generate insights from similar data. And for how long I've researched to prepare for the switch, I think uh, uh, I I think it took me around one one year to fully transition from a web development to a machine learning like an engineer, because I was able to get guidance from my mentor in MatcHub. So because when I started the transition, I already had quite a lot of experience in the full stack development. So not only the front end but also the back end working with database, and I also know a bit about Python. So the steps were just to learn more about the data processing library in Python and be familiarized with it. And yeah, I think doing real life project also helped. So I hope that answer your question.
Great. I think yeah, and we have another question from Mintu. So yeah, and he actually applaud and said it's a super interesting project. So what would say is the biggest advantage that having being a web developer gives you in AI space?
Uh, I think not only in web development but software engineering in general is that, so I'm a CS student, so I think my experience in like because of like how web developer and like software engineering works, we also work with the DevOps, and I have a bit experience in that, like writing tests and like learning different software engineering principle in NUS. So I guess that would help me to maintain a better quality standard and help me to easily collaborate with my other teammates or other colleagues in the company.
Okay. Yeah. So I think we have one last question from Jet. Yeah. So what are some things that machine learning engineers should learn from the web developers?
Uh, that's a that's a good question. Uh, mm,
What
there
about
isn't
something? Okay, go ahead, Mark.
because there isn't like a very definite answer that I could come up right from my head, because I come from a web developer background. Maybe I assume something that that machine learning engineer would know, but because of my background, that just give me the advantage over machine learning engineer. So I couldn't come up with an answer straight away.
Hmm. Yeah.
Uh,
No
yeah.
problem. I think if audience has more questions for Mark, you can actually connect with him on LinkedIn. Yeah, so maybe you can actually give you some of his advice and experience over there.
Uh-huh.
Okay. So yeah, so we will thank you Mark for a good presentation. Yeah,
Thank you.
so I'll move you backstage and we'll invite the third speakers for tonight. Okay. Yeah, thank you Mark. Okay. Hi Rama. Uh, Rama, I think your earpiece still have some issue. Yeah, so we still unable to hear you clearly. Yeah, no problem. We rectify the, the technical issues. Maybe we can have the last speaker connect to you again. Okay.
Where
Yep. Okay. Now, while actually Rama is actually solving technical issue, we will invite the last speaker first, data influencer. So so we have three speakers for this team. Yeah, hi, Xingyi, Wei Ning, and Rose.
Wow, three ladies in AI, very motivating and powerful.
Yeah. So I guess it's gonna be a bit difficult because I think I know that you guys are actually sitting around each other. So maybe you guys can actually just open one mic and then you can answer some of the questions. Okay? Yeah. Okay. So actually, before we start the presentation, right? Actually, I'm actually quite curious. Like, how do you all form this team? Yeah.
Right. Yeah, first of all, thank you for having us. We're excited to be here. How we formed this team? So we got to know each other first from a smart city interest group that we joined together, and we served together in the community as well. Then we did projects, data science projects in school together, and we came across this AI impact hackathon that was looking for teams of two to four, and we were all interested in the area of healthcare and how data science is applied there. So there was a problem statement on that, and that was the problem statement we chose, and that's how we formed the team to do this solution pitch together. Yeah, which is what we're gonna share today.
Cool. Okay. So yeah, I think let's not waste any more time, and then maybe we can take the stage. Okay. All the best.
Okay, thank you. So what if COVID was detected earlier? Imagine the number of lives that could be saved. A very good evening to everyone. I'm Rose, and here today with my teammates Weini and Jinyi. We are currently Year 2 students from SMU, majoring in Smart City Management and Technologies. So our problem statement that was proposed to us looked at how we can use data analytics to predict or prevent the next pandemic. And our solution is to make use of social media for the surveillance of pandemic risk to improve real-time pandemic detection. Imagine if there is a pandemic wave arising among the population and more people are showing flu symptoms. And let's say you are one of them. With your schedule planned out for the week, you probably will not report to hospitals immediately. However, you might just tweet about your flu symptoms as part of your daily update or just to vent some distress. As such, we see that current surveillance methods using hospital records can face challenges such as late reporting and underreporting, as well as high costs for training and testing. But if infections could be captured early, outbreaks could be detected fast, allowing interventions to be made early too. So here is where our solution comes in. Using real-time, high-volume social media data, our solution can detect health statuses early, reducing time lag when reporting and improving real-time surveillance. In addition, as a complement to existing surveillance methods, it also serves to increase detection coverage at a low cost.
Our solution starts with training our model to identify social media posts indicative of infection. Taking Twitter as an example, we will first scrape tweets containing keywords relevant to respiratory infections for periods with no pandemic periods. Keywords could be determined through literature reviews and domain expertise, and some examples would be flu, catch, sick, cough, fever, got, eye, me, and head. Yeah. So we will scrape all the tweets containing the keywords for the day and filter out tweets that are not indicative of infection using a trained SVM model. So for example, SVM will be trained to categorize down with flu today as indicative of infection. This volume of tweets categorized as indicative of infection will be used to estimate the number of cases of respiratory illnesses. In order to predict the number of cases in normal circumstances without pandemic, we will combine offline datasets such as hospital data and climatic records with past tweets indicative of infection. We will then use a LSTM on this dataset to make a prediction about today's case numbers. We will then employ statistical methods to find the deviation between the estimated actual number of cases and predicted cases. And the level of deviation between the predicted number and actual number will then correspond to the calculated pandemic risk. So this pandemic risk is determined with statistical tools. So using the z-score values, the more it deviates from 0, the higher the calculated pandemic risk. When a certain threshold is reached, for example, when the z-score is higher than 2, The model will alert authorities of a potential outbreak, and the SEIR model will be employed to forecast the pandemic trajectory. We also propose plotting a real-time pandemic risk as an accessible way for decision makers to observe patterns to make more timely and better informed choices. The further it deviates from the predicted value, and the darker the color on the map.
We propose using a support vector machine for classification of tweets as indicative of infection or not indicative of infection. SVM is a supervised classification model that can be used for multidimensional data. The idea of FCM is that it finds a hyperplane that maximizes the margin between data points of the two or more classes. In this case, we will use SVM to find a hyperplane that can separate tweets indicative of infection and tweets non-indicative of infection. We chose it because it is effective for short text classification and has promising results for detection of health-related tweets from past studies. We propose using a long short-term memory model for time series anomaly detection of infection tweet volume. LSTM is a recurrent neural network mainly used for sequential data. We chose it because it is well suited for making predictions based on time series data and can learn what information to retain and what information to forget over time. The main reason we chose LSTM over other sequence-based learning methods is because LSTM is relatively insensitive to the amount of time between data points and thus can retain information from a long time in the past. This is important for our situation as there is a seasonal trend in respiratory diseases, and so LSTM's ability to retain information from the past will allow it to be able to learn past flu trends, and this will be during non-pandemic times. Furthermore, LSTM is able to take in multidimensional data, which could allow us to feed in data from both online and offline sources. Reflecting on this experience, some of the challenges we face include lack of domain knowledge and familiarity with relevant models. Hence, we reviewed literature and research models for time series detection and classification. In addition, Twitter datasets may not be a holistic representation of the population. However, we could explore the usage of other social media platforms like Instagram and the usage of offline data sources to broaden our data set. Lastly, there is also the difficulty of model explainability. But using SHAP, we could use it to understand the contribution of each feature to the prediction. We have come to the end of this sharing, and we're open to any feedback and suggestions you may have for our proposed solution. Thank you.
Yeah, thank you for the presentation. Okay, so for the audience, right, if you miss the previous presentation, don't worry. You can still visit our Google Developer Space YouTube channel. You can rewatch the session. Okay, so now let's see if we have any questions for you girls. Yep. So hi, cool. Yeah, just want to say hi, and yes, Mintu has a question. So yeah, and very relevant project. Which step of the project do you expect to be the most challenging and time consuming?
Yep. I think I can take this question. I think I'll move back to the slide to have the flow of our solution. Yeah. So I think for us, we think that scraping and also cleaning the data, preparing it will take out the bulk of the time, because scraping data from Twitter or social media platforms in general, I think take quite a bit of time. We actually tried a similar project to this for one of our class, which is computational social science. So what we did then was also to scrape Twitter data to find out people's sentiments on plant-based meat. So when we were doing that, a lot of the time we took was on just having the data to load, having the data set, preparing it and cleaning it for the model itself. Yeah. Although I do think that training the model and also having the model to run will also take quite a bit of time. Yeah. I don't know whether Rose or Xingyu has anything to they want to add on.
Yeah, any like Xingyi or Rose, do you have anything to add on? No? Okay, great. And then we have another question from Jet. Yeah, so yeah, how performant was the model given not many Singaporeans use Twitter?
Yeah, actually for this model, it was actually really a proposal so we also know that actually the Singapore population, not a lot of us use Twitter, and we are maybe more active on platforms such as Instagram or like maybe some other platform lah. So yeah, we do think that this model may have its limitations. That's why we also propose like incorporating different forms of data sets, which is not just limited to Twitter. And actually, like we really want to, we haven't really implemented this, but we ourselves are looking at this summer to maybe develop this into one working kind of model lah. Yeah.
Okay, great. Okay, so thank you for your presentation. Yep, so now we'll move on to the last speaker for tonight. Yeah, so thanks, Xingyi, Rose, and Winning. Yeah, I'll move you girls backstage. Okay, bye. Okay, so next up we have Rama. Hi,
Hello.
Rama.
Are you able to hear me well?
Yes. Yeah, I think
Okay,
maybe
that's great.
the airport there is actually not working. Yeah, so it's okay. Yeah, we can hear you loud and clear right now. Yep. So let me bring up your presentation. Okay. Yeah. So okay, can you everybody see that? Okay.
Okay.
Yeah. So okay. Yeah. So yeah. Before so now that it's all good, so you can the stage is yours. So you can continue with your presentation.
Okay,
Yeah.
thank you. So,
Okay.
hi everyone, I'm Rama. I'm a year 2 computer science student from NUS, and today I'll be sharing about a machine learning project I did where we created a computer vision model to detect whether or not you're wearing a face mask. So, I'll start out with the problem. So, we came up with this when COVID first emerged and wearing face masks became mandatory. So, we wanted to come up with a process that will automate the checking of the whether or not you're wearing a face mask, so it doesn't require much manpower. So our solution was a computer vision model using deep learning. And this model will capture any violations when you're not wearing a face mask, for example, here, and it would capture it to be processed however they want it to. Yeah. So I'll start out with the data collection and pre-processing. So here was a data set that we used. So it comprises of images of people without masks and also images of people wearing masks. So one thing you will notice is that these masks do not look very realistic, and this is because the data was generated synthetically. So we used synthetic data generation because at that point in time, we didn't have a huge data set of people wearing real face masks because it was when COVID just started. So we got this data set from PyImageSearch, and they had artificially added face masks onto people's faces. And synthetic data generation is normally done when there's a lack of data or when there's class imbalance to make up for it. So after generating the data, we can see that we have an equal number of images per class, which is what we want. And another thing we did was image augmentation. Since our data set was relatively small, so we did things like rotation, horizontal flips, and zooming in certain parts of the image to represent a more real life situation where the images wouldn't always be consistently the same format. Yep. So now I'll move on to creating the model and deploying it. So we did it in Python using TensorFlow Keras, and we used transfer learning. So we used MobileNet V2 as the base model, and then we constructed our own head. We added a few more layers, which we trained with our data set. So the MobileNet V2 base model was frozen and we didn't train it. And we then combined the trained portion that we trained with our dataset, and we combined it with the pre-trained base model to come up with our entire model. Before we chose MobileNet V2, we experimented with a few different base models such as VGG16 and ResNet, and we found that MobileNet V2 gave us the highest accuracy for our use case, which is why we decided to use that. So how we deployed a model was with a web application, which my teammate worked on. So your laptop camera would capture a live stream, and every few seconds it would capture a frame from the live stream, which will then be processed. So how it's processed is that we have a ready-made a Haar cascade face detector, which crops the input frame to only the face, so only the face portion, and then it will feed just that into our face mask model, detecting model, and then our model will return the output of whether or not it's predicted to have if the person is wearing a mask or not, and then we display it on the screen as such. So what we noticed after analyzing and evaluating our model in different situations is that, so as you can see in this photo, the person is not actually wearing a mask. He's just using his hand to cover his face, but our model classifies that as he's wearing a mask. So one reason we can think of is that because our data set of masked people was generated synthetically, so maybe having a more authentic data set with real masks would combat this issue. And another way is by adding such false positive images of people with their hands over their face into the no mask category of the data set. So the model learns it as they're not actually wearing a mask. And the second problem is that since we used a face detector to capture the face from the webcam before feeding it into our model, that face detector was trained on people without who are not wearing masks. So when we fed in images of people with masks, the faces were sometimes not recognized by the face detector. So to improve the project, we would then further train a custom face detector model with masked faces as well. Yep. So that's the end of my presentation. And if you have any questions, you can put them in the chat.
Thanks for sharing about this project, Rama. I think they can also replace some of our safe distancing ambassadors. Yeah. What is your greatest takeaway from this project?
My greatest takeaway from this project is I think I realized the importance of the data set, and I realized that there are many issues to combat not having real world data, such as by synthetic data generation, because prior to this project, whenever I read about AI projects, it was always using real world data. And I found that not having the data was a problem when I thought of my own possible projects. But after learning about synthetic data generation, I realized that it's a very powerful tool that we can use to model real world situations. Yeah.
That's cool. And I think this is related to one of the questions that Terence asked. Can you explain a little more about how you generated the masked faces?
Okay, so for the mask, the data set, actually, we got it from PyImage search. So what they did is that they developed their own algorithm to notice facial landmarks on the face and then add on a mask photo which was fed in onto the specific landmarks where a mask would typically be on. Yep.
That's interesting. And there's a question by Slossin. What about masks that are improperly worn? Example, they are not covering the nose or they are put down to the chin.
Yep, so that's one area of improvement. So for example, that would be similar to this situation where it would be a false positive. So in order to train the model that this shouldn't be considered as a proper mask, we can add such images into the no mask category of the dataset to further improve the model. Which our model doesn't currently do, but it's a area of improvement.
Yeah, sounds good. And do you have any advice for others looking to start similar project like yours?
For advice, I would say that there are many tutorials online on YouTube and websites that go through with you step by step on how to create models, and I found that very useful, especially at the beginning of my journey, because I found it intimidating to do something from scratch on my own. So I would say websites like PyImage Search, and there are many similar websites where you can follow along a guided project to familiarize yourself with like the workflow of a project, so you can do one on your own next time. So yeah.
Yeah, and there's also another question by Terence does this model work with side view faces?
Our current model doesn't, because our data set comprises of front view faces. So, but if we did include side view faces in our data set, then it should be able to work as well.
All right. Thanks for answering these questions, Rama. Very interesting project they are doing.
Thank you, Rama. Thank you so much for presentation.
Thank you.
Yep.
Thanks everyone for tuning in to AI Learners Launch. This is our first project, or rather event this year with Google Developer Space, and we are looking forward to more sort of such events together. Yeah, so do join us over at Discord, Telegram, and make new friends in AI, people from different backgrounds, and also start projects, work on hackathons like what our speakers have done today. So we do look forward to you joining us.
Yeah, yeah, and yeah, if you would like to re-watch the session, so you can actually go to Google Developer Space YouTube channel, and then you can re-watch the session. So and do remember to actually connect with us. And if you actually like the content, please go to Discord and tell Wei Ching about it. And then if you have any contents that you would like to listen or any topics that you would like to share, please approach us. And then hope you can actually be one of our speakers. Okay, so that's all for tonight, and we'll see you again. Goodbye.
Goodbye.